Okay guys, in this video we are going to be talking about probability. And probability is the chance or the likelihood that an event will occur. And the types of events we're going to talk about in this video are simple events. And a simple event is just simply one outcome or a collection of outcomes, and an outcome is the result of an action. So to clarify some of these terms a little bit, I've got some examples. So an example of a simple event would be rolling a number cube or rolling dice. And possible outcomes to that event would be a 1, a 2, 3, 4, 5, or a 6. So again, the event is rolling the number cube, and possible outcomes are 1, 2, 3, 4, 5, or 6. Another example of a simple event is drawing a card from a deck of cards. And possible outcomes would be, for example, the ace of spades, or 2 of diamonds, 3 of hearts, etc. There are 52 cards in a standard deck, so there are 52 possible outcomes. And also another simple event would be tossing a coin, and possible outcomes there would be heads or tails. So the language we're going to be using are events and outcomes. And how to find the probability of a simple event is the probability of the event is a ratio, and it's a ratio of the number of favorable outcomes. Now, favorable outcomes are the outcomes that we expect or the outcomes that we want to happen, over the number of possible outcomes or total possible outcomes. And the notation here is that capital P is just used to indicate the probability of, and then whatever you're looking for goes in the parentheses. So since this is a ratio, it can range from the smallest possible value of 0 to a largest possible value of 1. And those can be expressed as fractions, as decimals, or percents. So if you look at the scale here, we've got all the possible outcomes of probabilities here from 0 up to 1. Now, a probability of 0 means that it's impossible. It's just not going to happen. So for example, what's the probability that I roll a 7 on a dice, a standard dice? Well, that's impossible. That's not going to happen. So that would have a probability of 0 or 0%. And then as we increase our ratio, it becomes more and more likely to happen. And right in the middle of the road is 50-50. You've probably heard, or a 50% chance of something happening. That would be like flipping heads on a coin. There's a 50% chance that you're going to get heads. There's a 50% chance that you're going to flip tails. And then anything above 50% is considered likely to happen. It's more likely to happen than not. And then all the way up to certain. Something that is guaranteed to happen. So an example of something that would be certain is, what's the probability that when I flip a coin, I get either heads or tails? Well, that's always going to happen. That's guaranteed. So the probability of getting heads or tails when you flip a coin is certain, or a 100% probability. So let's take a look at some examples of probability scenarios and see if we can calculate some probabilities. A bag contains 7 pink, 2 white, and 6 blue marbles. 1 marble is selected without looking. We want to find the probability of blue. That means, what are the chances of drawing a blue marble at random? Then describe the likelihood of the event. Write impossible, unlikely, equally likely, likely, or certain. So I've got a picture or a diagram here of our marbles so we can see what's going on. And we want to know the probability of blue. So we're going to write this as a ratio. The number of favorable outcomes over the number of possible outcomes. Well, how many of these outcomes are favorable, or how many of these outcomes are what we're looking for? Well, we're looking for blue marbles. So these marbles here are all of our favorable outcomes. That's what we want or expect to happen. And how many of those are there? There are 6 blue marbles. And how many total marbles are there? There are 15. So the probability of drawing a blue marble out can be expressed as this ratio of 6/15. And we can simplify that ratio to 2/5. So a 2 out of 5 chance that you're going to get a marble. Or we can express that as a decimal, which is 4/10, or as a percent, which is 40%. So there's a 40% chance that you will pick out a blue marble from the bag. And we were asked to describe that as impossible, unlikely, equally likely, likely, or certain. Well, it's not impossible because there is a chance that it's going to happen, but it is less than 50%. So we would consider this unlikely. This event is going to be unlikely to happen if it's less than 50%. And then another example, what's the probability that we're going to pull out a white marble? So again, we're going to write the ratio of number of favorable outcomes, and there are 2 favorable outcomes in the bag, 2 white marbles, out of a total of 15 marbles again. So our probability is 2/15, which is in simplest form, or we can write this as a decimal, which is 0.13 repeating, or as a percent, which is 13 1/3%. So there's a 13 1/3% chance that we're going to get a white marble. And again, we would list this as unlikely to occur. It's less than 50%, but greater than 0%. Sometimes, since we need to know the total possible outcomes when we're calculating probabilities, it's nice to have them listed, all the possible outcomes. Like in the marble example, it was nice to see a picture of all of them. And when you list the set of all possible outcomes, that's called a sample space. And a sample space is just simply the set of all the possible outcomes to an event. So I've got some examples of sample spaces listed below. And a sample space for a roll of a dice would be 1, 2, 3, 4, 5, 6. All I did was just simply list all the possible outcomes. And there are 6 possible outcomes to rolling a dice, and I listed them. A sample space for a coin flip, heads, tails. Those are the only 2 possible outcomes, so I listed them, and that's my sample space. And lastly, the sample space for the previous marble problem, there were only 3 possible outcomes, blue, white, or pink marble. So I listed all of the possible outcomes there. Katie rolls a 6-sided number cube whose sides are numbered 1 through 6. We want to find the probability of rolling an even number, then describe the likelihood of the event. We're going to write impossible, unlikely, equally likely, likely, or certain. So again, the sample space is given 1, 2, 3, 4, 5, 6, and we want to find the number of favorable outcomes and write that as a ratio to the number of possible outcomes. So looking at the sample space, how many of these outcomes are favorable to us? How many of them are what we want? How many of these are even? Well, 2, 4, and 6 are even numbers, so there are 3 favorable outcomes. And again, there are how many total possible outcomes? There are 6 possible outcomes, so that is a probability of 1/2, 5/10, or 50% chance of rolling an even number, and this would be considered equally likely. You are just as likely to roll an even as you are to roll an odd, so equally likely. Next, what is the probability of rolling a 3, 4, 5, or a 6? So how many of these outcomes in our sample space are favorable? We want to find the probability of rolling either a 3 or a 4 or a 5 or a 6. So all of these are favorable outcomes. 3, 4, 5, and 6 are favorable outcomes. So there are 4 favorable outcomes out of the 6 total possible outcomes. That gives us a probability of 2/3, or 0.6 repeating, or 66 2/3% chance of happening. And we would consider that likely to occur. That is greater than 50% chance, but less than 100% chance. So we would say that is a likely event. Also, it's nice to know something called a complement to an event. And a complement is the set of all the outcomes that do not belong to a given event. So consider rolling the dice again. And if the probability of rolling a 1 is 1 out of 6, that means the complement to that event would be the probability of not 1 or not rolling a 1, because we would want all the outcomes that are not a 1. So looking at the sample space, 1, 2, 3, 4, 5, 6, the event was rolling a 1, so I have that circled. The complement would be all of the outcomes that do not belong to that event. So anything that is not a 1 would be the complement. So that includes a 2, a 3, a 4, a 5, or a 6. So the probability of the complement, or not rolling a 1, would be the other 5 outcomes out of the 6. So probabilities of 2 complementary events will always add up to 1 or 100%. The probability of rolling a 1 is 1 out of 6. The probability of not rolling a 1 is 5 out of 6. So those two added together give you all the possible outcomes. And it's nice to use complements sometimes to find probabilities of events. So remember the marbles? Again, I've got all my pink, blue, and white marbles listed here. And the probability of blue, again, was 6 out of the 15, or 2/5. So what's the probability of not blue? What's the probability that I don't get a blue? Well, then rather than figuring out what's the probability of getting pink and white together, I know that the probability of getting a blue is 2 out of 5. So the probability of not getting a blue has to be all the other possible outcomes. So that would be the remaining 3 out of 5. So the probability of not getting a blue has to be 3 out of 5, because 3/5 plus 2/5 is 1 whole, or 100%. And again, we can confirm that because if we look at all of the outcomes that are not blue, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 out of the 15 marbles are not blue, which is 3/5. So sometimes finding the complement is a faster or easier way to calculate the probability of a given event. Let's take a look at another example. What's the probability of not an ace when drawing a card at random from a standard deck? Well, that's much, much more likely than drawing an ace. So if I know the probability of drawing an ace, all the other possible outcomes are not an ace. So I'm going to use the complement to help me find this probability. So the probability of drawing an ace from a deck of cards is 4 out of 52. There are 4 aces, the ace of spades, ace of clubs, ace of diamonds, and ace of hearts in a standard deck, and there are 52 total cards in the deck, and that is 1 out of 13 in simplest form. So if the probability of getting an ace is 1 out of 13, what would be the probability of not an ace? Well, these two events are complements, so it has to be all the remaining outcomes that would add up to 1 whole. So it's got to be 12 out of 13. So the probability of not getting an ace has to be 12 out of 13, which is approximately 92.3%. So you have a 92.3% chance of not drawing an ace at random from a deck of cards. So using complements can be helpful when calculating probabilities of simple events.